morning, everyone. I hope everyone had a great weekend. We are going to start our last unit. It's the second half of chapter 11, and it's working with radicals. So we are going to work on simplifying radicals. And remember, radical is a square root, okay? And you can see we have a homework assignment here, and it says no decimal answers. And the reason is because if we're simplifying a radical, like the square root of 25, okay, that's just 5. But if we're simplifying a radical, the square root of 24, that's going to be a decimal on your calculator, and we are not going to put any decimal answers because those are rounded, and we want to be able to have exact answers at times. So the first thing I want you to do is pause the video and right now somewhere, either on the blank lesson you're following along with, or if you want to, you can do it, you need to have this available as we work through this next week or so. This is going to be really helpful and you're going to want to refer to it. So list all the perfect squares from 1 to 15, okay, on this paper. Pause the video and then see if you got them right. What we're talking about is 4 is a perfect square because when we take the square root of 4, we get 2 because 2 times 2 is 4. So pause the video and list all the rest of them. So this list, 3 squared is 9, 4 squared is 16, then we have 25, 36, 49, 64, you have 81, 100, 121, 144, 169, 196, and 225. You're going to use this list because you're going to look to see which of these perfect squares, all of the ones we just listed, are called perfect squares, go into a certain number under the radicand, or under the radical sign. All right, so we start out just simple. And if you have the square root of 25, yeah, that's just 5. Because the square root of 25 is asking what times itself equals 25. So that's simple, okay? The square root of 64 is also what times itself equals 64. And you could try these on your calculator if you don't know, but if you have this list, you can just look at it. Oh yeah, here's 64 right here, okay? And so 8 would be the square root of 64. All right, so, this is simple again. But what do you do with something like this? Well, we have to simplify what's under the radical sign first, which would give us 49, which then gives us back to 7. But what happens if we have the square root of 24? What do we do then? Well, this is what I'm talking about. We're not going to just take our calculator and get a decimal for that. It'll be like 4 point something, 4.9 something, okay? But we're not going to give a decimal answer. So we're going to use what's called the product property of square roots. And the product property of square roots says that if you have two numbers multiplied under the same radical sign, then you can separate and give each of those numbers their own square root sign so you can take the square root of them. So when we look at the square root of 24, there's many different numbers that we could break 24 into. We could break 24 into 6 times 4 or 8 times 3. But what we're going to look at is breaking it down so that this 4 right here, one of the numbers is a perfect square. And if we go back to that list, 4 is a perfect square. So we're going to always look for one of those numbers to be a perfect square. And why? Because then when we take the square root of 4, we get 2. The square root of 6 is not a perfect square, it's a decimal. And so our final answer, we just write it the 2 next to the square root sign, and that's 2 times the square root of 6, or 2 square root of 6. And that is simplifying radicals. That's what we're going to do today. So here are some notes to do that. These are the steps to simplify radicals using what's called the product property. So I would pause the video, write down these 4 steps, and then listen to the explanation. First thing you're going to do is factor the radicand. That means break it down into 2 numbers that get multiplied together, 2 factors. That's the radicand is the number under the square root. And we're going to pick 2 numbers that multiply together to get that number. then we're going to also make sure we pick a pair where one number is a perfect square. So if we go back to that example that we had on that last screen, we'll just do the same one, the square root of 24. Okay, we're going to separate that into two numbers that multiply together to get 24. So we're going to have two numbers, but one has to be, we have to pick a pair that has a perfect square. So like 8 times 3, that's 24, but neither of those are perfect square. But 4 times 6 is. So then we're going to break that down into the square root of 4 times 6. Then we're going to simplify. Using that product property, we are going to separate each of those factors under their own square roots, and then that will give us the square root of 4, which is 2, times the square root of 6, which is simply just written 2 square root of 6. There's an implied kind of times signal in between that we don't necessarily need because it's understood. All right, now this is tough stuff, okay? But don't give up. Keep trying, follow along. I would for sure follow along on this lesson, so pause the video right now and go find the blank lesson or pull up Notability so that you can follow along with this. All right, the square root of 8. Okay, I have to break that down into two numbers, one of them being a perfect square. Well, 4 is a perfect square, and 4 times 2 is 8. Now I'm going to separate using the product property and give each one their own square root sign. And that's going to give me 2 times the square root of 2. And then that's my answer right there. Square root of 18. Okay, what goes into 18? Well, 6 times 3. But if you go back to that list, this is why it's so important. If you go back to this list, is 6 or 3 on the list? No. So you're not going to use 6 times 3, but what is on the list is 9. So 9 is your perfect square times 2. 9 times 2 is 18. Then we separate, give each number its own square root, and then this gives us 3 times the square root of 2, or 3 square root of 2. That's your answer. Okay? Okay, you try number 6. Pause the video, try it, see if you can get it. Well, 6 times 2 is 12, but neither one of those are perfect squares, so don't pick 6 times 2. 4 goes in there 3 times. 4 is our perfect square. Then this gives us the square root of 4 times the square root of 3, which is equal to 2 square root of 3. Now these get more challenging when the number is bigger. So again, you look at this 75 and you're trying to rack your brain. You're like, well, 5 goes in there, but 5 isn't a perfect square. So look at your list. Look down the list that you wrote down. Well, 25. 25 is a perfect square and it goes in there. 25 goes into 75 3 times. Now we give each their own square root sign using that product property, and we get 5 square root of 3. All right, so that's what we're going to be working on. Okay, if you encounter something like this where you're multiplying two square roots, now you kind of use the product property in reverse. So if these two things right here, these two square roots are multiplied, okay, then you can put them back under the same radical. Just like we separated, we can pull them back together. And then that gives us the square root of 8 times 2, 16. Oh, well, hey, the square root of 16 is 4. So those looked like pretty ugly problems, but we end up with 4 in the end. So moving on, okay, number 10. If we put them back together, we get 10 times 30, which is the square root of 300. Okay, so now you have to keep going though, because the square root of 300 isn't a perfect square, but what perfect square goes in there? Look at your list. Look at the biggest numbers first, so you get the largest square root. Well, 100 times 3. So now I'm going to take the square root of 100 and the square root of 3, which gives me 10 square root of 3. All right, why don't you try number 11? You can multiply those two numbers on your calculator. That will give you 81. Well, then that should be easy because the square root of 81 is 9. Now, if you take a look at number 12, we could multiply those back together. But if you already see that one of these numbers is a perfect square, then I wouldn't bother doing that. Okay, so I already see the square root of 25 is 5, and the square root of 49 is 7, so now I just have to take 5 times 7, which gives me 35. So that makes it a lot simpler. All right, we got two last problems here, and then we'll get you practicing on your own with the homework. So again, we have to simplify what's under here first, so we're going to have to add those together. So the square, when we add those together, we get 54. Now, you have to, again, what number goes into 54? Well, look at your perfect square list and notice that 9 times 6 is 54. And the square root of 9 is 3, and the square root of 6 can't be simplified anymore, so there we go. Now that last step in our process, I always said go back and see if you can simplify more, because if you don't pull out the largest perfect square here, then you're going to have more to simplify. So always try to get the largest perfect square that goes in there. And this last one, again, I would just separate them because they're both perfect squares, and that gives us 6 times 4, which is 24. Now, I'm going to also put in the resources a multiplication chart. I did not include it in this video, but a lot of times students will find it easy to find the number on the multiplication chart just to see what numbers go in there. So I'll put that in the chapter 11 folder also as a resource for you. So good luck. Don't give up. You might want to re-watch the video a second time, and you also might want to look at section 11.6. That's where the homework's coming from, and read the section. Tomorrow we're going to do another day of this, but we're going to make them a little bit more complicated, and we're going to add variables. All right, have a great day, everyone.